This lesson is about writing sinusoid equations when you're given points. Specifically, the points that you're going to be given are frequently going to be a maximum and a minimum point, such as the example I have here. I've been given a minimum point to the left here and a maximum point to the right. Now, I like to sketch this out a little bit and just be able to visualize what's going on. So I make some reference lines for myself of where the maximum is going to be and where the minimum is going to be. I'm going to make some calculations based on the points that I have. I know that the amplitude A is the highest point minus the lowest point divided by 2. Watch your signs. So the A value is going to be 3. I know that my vertical displacement is the mean value. So that's the sum of the values. Again, watch your signs, divided by 2. So I have my A and my D now for the sinusoid. I'm going to plot that D as a reference dotted line, the mean value line that's normally on the y-axis but has been translated 2 units up. Okay, next thing I'm going to do is I'm going to count squares and recognize that it looks like 1 square horizontally is pi by 6. So if I count to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9 pi by 6 or 3 pi by 2 is correct. And I've got a total horizontal span here of 10 squares between the max and the min. So 1, 2, 3, 4, 5, halfway point. This is where my mean value is going to be. And I'm just going to plot a smooth curve from the max down through that mean and down to the min. I'm just going to continue on. Whoops, we'll do a little better job than that. It's going to continue back up from there in a periodic nature, and it's going to go from the max back down to the min. Now, what I'd like to figure out next is the period, and the period is twice the spread from the max to the min, because that's only half of a cycle. So I'm going to take that 3 pi by 2, I'm going to subtract the negative pi by 6, again watch your signs, and this is going to be 9 pi by 6 plus pi by 6, so 2 times 10 pi by 6, or 10 pi by 3. That's my period, an unusual period. We're used to a period being 2 pi. From the period, I can figure out the horizontal expansion or compression. It is 2 pi divided by the period. So I will write 2 pi times 3 over 10 pi, the reciprocal. Fraction was on the denominator. 2 pi 10 pi reduces to make a b value of 3/5. So what I have is a horizontal expansion by 5/3 on a 2 pi period. All right, so let's just make note here of what I have so far. I've got my A value, my D value, my B value, and I probably should have written down clarifying to remind you what I mean by the A and the B and the D. A is the amplitude in front of a cosine or sine wave. B affects the shape, C affects what's called phase shift, the horizontal translation, and D is the vertical displacement. So I have found 3 of the 4 transformation effects. Now, C is the trickiest of the bunch to find. To find C, I need to decide if I'm doing cosine or sine. Now, cosine, if you recall, is based on the peak value normally being on the y-axis, while sine is normally based on the mean value, which goes through the origin. So if I'm going to use cosine, I'm going to want to refer to point A in my graph above, or B. I'll talk about B in a moment. Now, if I'm going to do sine, I'm going to use point C, the mean value. I'll just write U's in front. These are my references that I'm going to refer to. If I'm using A for cosine, this point is normally on the y-axis. It's been translated to the right, so it's a horizontal translation to the right of 3 pi by 2. So my C value in the equation is 3 pi by 2, representing the movement to the right. If I were to use the point B, that's the minimum point. Well, now I've horizontally translated to the left pi by 6 and reflected So my c is going to be negative pi by 6, and my a is going to be a negative value in the formula above. Now, if I were to use point C and do a sine curve based on the mean value that's normal at the origin, it's now over here moved 4 squares over, or 4 pi by 6, or horizontal translation to the right, 2 pi by 3, 4 pi by 6 to the right. Okay, I've already got right written down. So let's make some equations based on these. Using A, so I'm using the maximum value, so I'm going to write y is based on a cosine curve because I'm working with the max. The amplitude, let's see, I had that up above here. The amplitude is 3. The vertical displacement I'm going to put at the end is 2. Now, the cosine function has a b value of 3/5 representing the expansion, and x is translated to the right, so minus 3 pi by 2. Close the brackets. So everything in here, all of this is representing the concept of an angle using a domain or input value of x that is both horizontally expanded and translated. Then the vertical effects are tripled and 2 more is added to it. So while I'm on this, let's just talk about the range of this function. The range of this function goes from plus 3 when cosine is 1 to minus 3 when cosine is minus 1, and I always add 2. So I can say this, the y value is 2 minus 3 all the way up to 2 plus 3, or it goes from negative 1 to 5. Now look up above at the graph. Sure enough, the lowest point was negative 1 and the highest point is 5. Okay? Cosine of an angle varies between negative 1 and 1, you'll remember. I multiply that by 3 and add 2 to get the range. Anyway, that's how to calculate the value from reference point A. So there's one equation. Let's do C rather, and make a sine equation. The amplitude's unchanged, so I'm still going to write 3. Now using sine. The period for a sinusoid is normally 2 pi, and it's horizontally expanded, so I'm still using 3/5. I said I translated right, so that's a minus sign. The value is 2 pi by 3. Close the brackets, and remember, all of that is representing an angle idea. The 2 pi by 3, let's look back up here. I'm using this point C, and it translated to the right 4 squares. I have vertical displacement of 2. So this graph apparently is equivalent to this other graph. Pardon me. Now I'm going to do one more. I talked about point B. If I use point B, that's the one that I referred to over here as the minimum value. Well, I'm reflecting now. A max has become a minimum. So it's going to be a minus 3 now. Amplitudes are always positive, so the minus in front just represents a reflection. It's cosine because I'm working with extreme values, max or min. The period is unaffected, so the b value is unaffected. The vertical displacement's unaffected. My input's still x. But if I'm working from B, it moved to the left by pi by 6. So I'm going to write plus pi by 6. So all of these equations should be equivalent to each other. We can get our calculator. I've already written the first one into the calculator. And what we're going to need to do is we've got to think about the window, and we've got to think about what types of angles we're working with. So let's go to mode once you've got this entered. If you need to pause to do it, go ahead. Now we go to mode, and we need to make sure we're in radian mode because we're talking about real number values, not degrees. Then, pardon me, we need to go to the window. X represents angles in degrees, and I'd like to see a fair bit of this graph. So let's go negative 2 pi to positive 2 pi as an idea. We may need to adjust this. And let's scale it by pi by 6, just like we did on our graph paper and like we've been doing in class. My minimum value we established was negative 1, and my maximum is 5. Scaling by 1 should be just fine. Let's graph that. Okay. Now you'll see we had this point, the minimum, just to the left and down low, so that's consistent, and we had a maximum over here in quadrant 1. This is looking correct. And the mean value, these are 1 unit, so 1, 2, 3, 4, 5. The mean value is right along this line, and sure enough, 1, 2, 3, 4 squares over. So this is consistent. Now here's the real test. Let's try entering that sine equation and see how we do with that. 3 sine 3/5, open another bracket. You got to watch your brackets with these. There's quite a number of brackets, and you have to pair them up and make sure that you are putting things in the right place there. Close both brackets, add 2. Now I'd like to do something else just before I graph this, because I suspect they look the same. They should. I'm going to make this graph bold so that if it graphs as the same thing, we'll be able to see it show up because the second one will be bold. Let's watch. Here's the first graph is already done. Yep, the second one's lining up right on top of the first graph. So we were successful, let's go back, in making a sine equation that's equivalent to a cosine equation. The amplitude is the same. The period, and therefore the horizontal expansion in this case, is the same. Vertical displacement is the same. The only thing that changed is cos to sine with its relevant reference point. I'll leave the third one for you to try using the reflection and the minus sign. You should see that it lands at the same place as well. All right, good luck on working with these questions.